This key concept from chapter 1 is the classic vision of the scientific method, that observations lead to hypotheses that make experimentally testable predictions. So the scientific method can be formulated many different ways. The way in our book that we're going to learn is the steps that follow. Number 1, we make observations and do research. Number 2, we form a scientific question. Number 3, we form a hypothesis, which is going to be a predictable statement that allows us to test that question. Then we test the hypothesis with an experiment. It can be observational or it could be manipulative. And then we're going to analyze the results and find out if the hypothesis is supported or if it's refuted. Then we'll revise the hypothesis if needed and share the results with the scientific community. So a few things about experiments and the scientific method that are important are variables. So variables are things that are going to change over time. And there's two main categories. There's independent variables. These are factors or conditions that you are manipulating in the experiment. So it's really what you want to test. What is the effect of light on plant growth? So then you're going to be looking at changing the independent variable of light, how much light exposure there is, and the dependent variable is going to be the growth of the plant. So that's what you observe in response to the independent variable. So the dependent variable is going to be affected by our independent variable. Again, the hypothesis is a predictive testable statement. So this is formed in response to the question. So if you want to know how will light affect plant growth, that's our question. And the hypothesis is going to have a period at the end. So it's something we can measure. So for example, the hypothesis may be that increased light will increase plant growth, period. Then you test it, you increase the light, you measure the growth, and then you support or refute your hypothesis. A control group is going to be the standard of comparison to which we are going to reference. So the treatment group has the change in light, and we're also going to create a group of plants which have no change in light. So they're going to be what we're referencing. So we have a standard amount of light for plants, what they're accustomed to. We're going to increase the light, and then we're going to see if in that treatment group there is a change. The control group lets us know that it's not just some natural phenomenon that the plants are going to be in a developmental stage where they're going to increase and the light didn't really have an effect. So this allows us to isolate the variable by forming a control group or a reference. So the treatment group is the one that would have no, that would be affected. All right, and that's it for that concept.